Hello students and welcome to the 5th semester, and here I'm going to teach you graph theory, and this is an elective subject in your mathematics. It is also related to your maths only, but this is an application oriented subject in mathematics. And here you are having 5 units in this. And about this subject, I've already given you the syllabus, and the syllabus covers 5 units. Out of this, the first unit I am splitting it into two parts and giving you the first part in this PPT, and the second part will be continued in the next PPT. Here I am going to deal about the simple. What are the topics covered inside this first unit is simple graphs, multigraphs, digraphs, bipartite graphs, subgraphs, degrees, handshaking theorem, and these are the things which I am going to teach you. And why we are studying this graph theory? First, you should know what is the importance of this graph theory, where all it has been used. So, why we are studying means it is used to model pairwise relations between two objects. Any two objects or any three objects, whatever it is, when you are modeling it, the pairwise relation, how you are making the relationship. And generally, when a network can be represented by a graph, how a network can be represented by a graph here. And many practical problems can be easily represented in terms of graph theory. So many problems we have been solved in this graph theory, and what are the problems we will be dealing here. And the history of graph theory. The first important thing is the origin of graph theory. This can be traced back to Euler's work on the Königsberg bridges problem in 1735, which led to the concept of an Eulerian graph. The study of cycles on polyhedra by the Thomas P. Kirkman and William R. Hamilton led to the concept of Hamiltonian graphs. The types of graphs are there, and here the Eulerian, he discovered about the Königsberg bridge. What is this Königsberg bridge? And began in 1735, mentioned in Leonhard Loyola's paper on 7 bridges of Königsberg. The problem of walking on all 7 bridges without crossing a bridge twice is, can you solve this problem? There is a land area between these 2 bridges, and we are crossing all the 7 bridges should be crossed without crossing the bridge twice. This is how he was trying to do it. Whether it was possible or not, we'll see it at the end of this topic. And the applications of graph theory. A graph theory has a wide range of applications where all it has been applied in many fields like engineering, physics, social, biological, chemical, and linguistics, etc. It's used to study the molecules in chemistry, social networking, and biology and conservation efforts, mathematics, especially in OR related thing. OR means it's operation research. You already started this operation research one, and I think your subject is being covered. And geometry, knot theory, and algebra. Computational theory, intelligent transportation system, digital graphs, social media. These are the things which are there where it is applied. And important definitions of, now we are going to know many definitions are there. Please make a note of all the definitions. These are very important thing in the graph. Without this we cannot do what is graph and all. Please do mark this one. The definitions are more important, and also this graph is not the same as you studied in your 10th or 12th standard. The graph they studied is about x-axis and y-axis and plotting the points and making an equation and like that and all. But here the graph is about drawing a polygons. This is not about in the graph which we did like that. So what is definition about the graph? A simple graph G of VE consists of a non-empty set V of vertices and a set E of edges such that edge E belongs to E is associated with an unordered pair of distinct vertices called its endpoints. So first of all, a graph means it is a simple graph. It is containing vertices and edges. What is a vertex? What is an edge? These are the vertices or points. Edges or line joining between two vertices points. See here, vertices, I am drawing a graph like this, and here, and this point A, and this point B, and this point C. And these are the points. I have drawn a diagram. This diagram is just a triangle type, and here the ABC denotes the vertices, the points, And edges are the line which is joining between A and B and A and C and B and C. This denotes the edges. So edges means line between two vertices or 2 points is called as edges. Vertices means the points along. So now in this graph, V is equal to A, B, C, D, because there is a graph here A, B, C, D, and the E point is something which is different, and they have drawn a diagram here. So what are the vertices means? The points, all the points should be included. So A, B, C, D, E. And what are the line edges? Edges means it is a line between 2 points. A to B is a line and B to C is a line. A to C is one more line. A to D is one more line. So 5 vertices and 4 lines are there. So the 5 vertices and 4 edges are there in this graph. Now vertices are, what are vertices? Vertices are adjacent. If there is an edge connecting the two vertices, if there is an edge between two vertices, then it is adjacent. An edge is incident to its endpoints. Endpoints, if these two endpoints are there, it is incident on that endpoints. In graph theory, a loop. What is a loop? A loop means if I take a point like this, I am taking a point like this, and this point I am going to draw a loop for this point. Means you are just drawing a line like this. This is called as a loop for this. A simple graph contains no loops, but a loop is an edge that connects a vertex to itself. It is connecting the same vertex to itself. So I can draw like this. So you can, if I take a point like this, I am taking a point here. I am going to draw. I am going to make a loop. Loop means from this point to this point itself you can draw like this and finish the loop. This is the loop. It has formed the loop. That's it. It is about loop. So take one single point, you are drawing a point to its you are making a point. This is called as loop. You started here, the starting and the end points are same. So that is it forms a loop, self loop. In some next we go for parallel edges or multiple or parallel edges. In some directed as well as undirected graphs, we may have pair of nodes joined by more than one edges. Such edges are called multiple or parallel edges. Directed as well as undirected, we don't go for the undirected graphs now. It's just a graph we take. We may have pair of nodes joined by more than one edges. Just if I take these 2 points, if I joining like this and again I join with this is called as a multiple or parallel edge. So it can go from here, again it can come from here. These 2 points can be linked like this, and this is called as parallel edges or multiple edges. Directed graph, also called as digraph. Edges are ordered pairs of vertices as opposed to a 2 element set. See this in this diagram, A, B, C, D, E. All of them are given. Some directions are given in this. So first of all, A to B there is an arrow mark. Here it is linked as this arrow. And from B to C there is an arrow mark. And B to D is an arrow. D to C there is an arrow. And C to E and E to D. So this directions, if it is mentioned, then it is called as a digraph. And next one, it's about multigraph. Multigraph, where it is used, a pair of vertices may be connected by more than one edge. Formally is not a set but an unordered vector or sequence of edges. See, this is type of tool. When I partition it, we can get two. There were two. If I do like this, and this is one graph and this is one graph, so it represents a multigraph. 2 or more than graphs can be, you can split and get it from this into an unordered vector sequence of edges. See, this B to C is the A, B, C, D, E, F. So A to B and B to C. Again from C to B is also, because it's the parallel edges there, because B to C is there and C to B is also there. And then from B to D is one point and C to D is one point, D to E is one there, and D to E to F, 2 parallel edges and also one straight line is there. So this is called as a multigraph. And weighted graph. What is a weighted graph? If I say that, if in this graph, if I draw a graph like this, and this graph I am representing it A, B, C and D, and if I do some measurements or write something like this, and A to C it is 3, and A to B it is 4, and B to C it is 5, and C to D it is 7. And this sort of measurements are given in length or something like that. Then we say this is called as a multigraph. And next one is pseudograph. A multigraph with a loop is called as a pseudograph. For this example, see in this example they are drawing one line, and in this one, this is a graph with a, and B is a point which is having a loop, and this sort of graph with the loop is called as a pseudograph. Any simple graph doesn't have any loops. A simple graph will not have any loops, and this is a multiple graph with a loop, so that is called as a pseudograph. A simple graph is an undirected graph. It is, now see for the definition of simple graph, it is an undirected graph with no parallel edges and no loops. A simple graph will just a diagram will be there, that's all. A simple graph with which has n vertices. The degree of every vertex is at most n minus 1. And to know about the degrees, I'll go for the next one. Now, what is a degree? Now here see this graph is having some points are there. It is just like a pentagon, and but it's not a pentagon. You are drawing like this, and it's not joined fully, all the points are not joined. See this here, and it has been extended like this. And this graph is a simple graph. It is having n vertices. How many vertices are there? 1, 2, 3, 4, 5, 6, and 7 vertices are there. If I draw from this 1, 2, 3, 4, and this one is a 5th point, and 6th point, and this one is 7. So it is having 7 vertices. And the degree of the vertex, if you count it, it should be n minus 1. If the degree is equal to degree of this graph is 6, then we say that this graph is a simple graph. It is one less than the vertices. Then it is called as a simple graph. What is a null graph? Here, a null graph is a graph in which there are no edges. There are no edges between its vertices. A null graph is also called an empty graph. And this is also called as an empty graph. See here, I mark points like this. And this is 1 point, and this is 1 point, and this is 1 point, and this is 1 point. And these are points, this called as a null graph. 3 points are there. Some 3 points, 1, 2, 3, or 4 points we have. But it is not joined. There is no edges between these points. And only the vertices are there. So this is called as a null graph or an empty graph. And next about complete graph. What is a complete graph? In a graph theory, a complete graph is a simple undirected graph in which every pair of distinct vertices is connected by a unique edge. A complete digraph is a directed graph in which every pair of distinct vertices is connected by a pair of unique edges, one in each direction. See here, a graph theory. Complete graph means it doesn't have any directions, but the vertices will be connected. That is called as all the vertices are connected. See here in this triangle, 3 vertices are there. This is a triangle only. It's a triangle. 3 points we are taking it and we're joining all the 3 points. So it is that all the 3 vertices, all the 3 points are connected. A, B, and AC and BC are connected. So this is called as a complete graph. And here see ABCD, and this is also a complete graph because it is all the edges are connected. A to C, A to B, A to D, and also C is connected to C to D, and C to B, and C to A. Like that, all the edges are simply connected. So this is called as a complete graph. And what is a bipartite graph? In the mathematical field of graph theory, my bipartite graph is a graph whose vertices can be divided into 2 disjoint and independent sets in such a way that every edge connects the vertex into one in one. You all learned about 1, 2, and a bipartite graph. Vertex sets and are usually called the paths of the graph. Vertex sets are usually called paths of the graph. If you split this graph, then also it is a different graph. That is called as a bipartite graph. It is divided into 2 disjoint and independent sets. When any graph which is splitted into 2 and is disjoint and independent sets such that every edge connects a vertex into one and one. A 1-to-1 graph This is your basing the graph theory is now going into your algebraic structure, where we are using is a one-to-one. In a one-to-one basis, then it is called as a bipartite graph. A degree. What is a degree? How we are finding out the degree of a vertex? Now I'm going for the degree of a vertex, and I already mentioned it previously here about degree, where you are using a simple graph which has n vertices. The degree of a vertex is at most n minus 1. Now I'm going for the degree. How to find out the degree? The degree of a vertex in a simple graph denoted by degree of v is the number of edges incident on it. A degree also means the number of adjacent vertices. See, adjacent vertices is also degree only, and the number of edges incident from that point is called as a degree. See, in this graph, and I don't go for that graph, I'm going to draw a sample graph like this: A, B, C, and D. What is the degree of A? At this point, I'm going to take it A, and this point is B, and this is point C, and this point is D. And what is the degree of A? Means A to C is one line, that is a edge, and A to B is one edge. What is the degree of A? Then the degree of A, we can represent it as degree is equal to 2. And the vertex is A. For vertex A, the degree is 2. For vertex B, how many degrees? Means it is having B to A and B to C. This point is connected from B to A, B to C. So this degree is also 2. From D also, the same thing follows, D to C and D to B. So the degree for this D is 2. From this point C, A to C to A and C to D. So you are having two more lines like this, and this two lines only from this point, from the point to where it is connected to the other point, other 2 points or whatever point, then we say this point as degree of the vertex. And here in this diagram which has been representing, now we go for the diagram. See here, A, B, M, H, T. A, M, H and T. 4 corners are there. Only 4 corners. But we are finding out the degree for this. That was a simple graph we did. But this one is something entirely different for you. See here, for M, this vertex M, I am going to find out the degree. How many degrees? So M to H is 1 point, and M to A is one line connected, and then M to T is connected like this. So 3 degree. This vertex M has 3 degree. And next, for A, how many vertex are there? See, I am going for the clockwise direction. Now I am going for A. And this A, how many degrees are there? So we can go, how many points have been joined from A? A to T is 1 and A to H is 1. A to H, how many lines are going from A to H? A to H, because A to H is joined like this. 3 times it is joined. A to H straight line is there, and type of loop is also there from here, from A to H. It is having parallel edges, parallel lines. So 3 lines and one more A to M. So 1, 2, 3, 4 and 5. So the degree of A is 5. Now, what is the degree of T? Now I am going for degree of T. Here, the degree of T is T to A is 1 and T to H is 1 and T to M. Don't leave that one because it is also joined. If the only thing, if there is direction, you can use only once the degree for that. If there is no direction, then you have to use both the ways. You have to take a line from here to here. From here to here, there is point, means you can take it twice. From A to T is also 1 degree. T to A is also 1 degree. If there is no direction mentioned in the graph, if there is direction, only one way you have to take the degree. So T to M is one more there. So T to H, T to A, T to M. So it is having 3 degrees. What about H? How many lines are there in the H? So H, and this H is connected by H to M, H to T, and then 3 more lines from H to A. H to A is 1 straight line and 2 parallel lines are there. So 1, 2, 3, 4 and 5. So you have got all the vertices as well as all the vertex, and how many degrees for all the vertex we have found out. See, what about handshaking theorem? We are now going for a theorem or a lemma here. How is we based on this? It states that the sum of the degrees of the vertices of a graph is twice the number of edges. If G is equal to V, E be a graph with E edges, then the degree is, then we say that summation of, then we represent that summation of degree of V is equal to 2 times of E. This is what we are going to prove now. The summation of all the degrees of the vertices is twice the edges. The sum of all the degrees of the vertices of a graph is twice the number of edges in a graph. Then we say that this handshaking theorem, everything is being related to other. The proof for this. Since the degree of a vertex is the number of edges incident with that vertex, the sum of the degree counts the total number of times an edge is incident with the vertex. Since every edge is incident with exactly 2 vertices, each edge gets counted twice, once at each end. Thus, the sum of the degrees is equal to the twice the number of edges. This theorem applies even if multiple edges and loops are present, and the theorem holds this rule that if several people shake hands, the total number of handshakes must be even. That is why the theorem is called handshaking theorem. Always, so if 4 people are there, the 4 people are shaking their hands. What will be the result of this 4 people shaking hands with each other? Then it will be a twice of that. It will be 8 times. That is what this means as handshaking theorem. The total number of handshake must be even. That is why the theorem is called as handshaking theorem. So if I am given by this problem, if I take one, I am taking a B, C, D. How many edges does D have? Or we can count like this also. A, B, C, D. So, A does, how many are there, degrees are there for A? A does have 2 degrees. And from B, how many degrees are there from B? B to A, B to C, B to D. So, B is having 3 degrees. What about C? C to B, C to D. So, 2 degrees are there for C. What about D? D is having D to A, D to B and D to C. 3 degrees. Can you count and tell what is this one? 3 plus 2, 5. 3 plus 2, 5. So, totally it is having 10. So, even only you are getting it. How many vertices are there in this one? 4 vertices. You are having 4 vertices. And the degree of the vertex is the number of edges incident with that vertex. The sum of the degree counts the total number of times an edge is incident with the vertex. So, here we are having 4 vertices, and how many edges means A to D, A to B, A to C, B to C and C to D and D to B. So, there are only 5 edges are there. In this 5 edges, because of the handshaking theorem, twice of E, we are going to multiply 2 times of how many edges? 5 edges. So, 2 into 5 which is equal to 10. See how we are writing the sum of the degrees here is equal to the sum of the degrees 2 plus 3 plus 2 plus 3 is also equal to 10. That is also 2 plus 5 equal to 10. Here, hence we prove that the number of edges is the sum of all the number of degrees is equal to twice the number of edges. So it is an even only. And next we are going to find out a problem. And the problem will be given. This also problems will be very easy for you to do. A simple graph G has 24 edges and the degree of each vertex is 4. See, 24 edges and degree is given as 4. 24 edges and degree of each vertex is 4. Degree of each vertex, degree of V is equal to 4. It is given. Each vertex degree. And the number of vertices only, we are going to find out the number of vertices. How many vertices are there? See, first of all, you remember the handshaking formula. What is the handshaking theorem? It is sum of all the degrees. How many degrees? You don't know. The number of vertices you know. Number of edges you know. So, what is the number of vertices into edges? The number of vertices you know and number of also edges you know. So, we take the number of vertices as n. I take the number of vertices as n. So, sum of all the degrees is equal to vertices. How many vertices and how many edges? 24 edges are there. So, 24 into 2. What is this 2? 2 times of E. 2 times of E is 24 into 2, which is equal to the degree. How many degrees? 4. 4 vertices are there. Degree of each vertex. So each vertex is having 4 degrees. It will be like this. So if I take one vertex, it will be having 4 types of way. That each vertex is having 4 degrees. So 4 into number of vertices, I don't know, n. So 4 into n is equal to 24 into 2. So 4 into n is 24 into 2. What is your n then? 4 how many times? 6 times you can cancel. So n is equal to 6 into 2, which is equal to 12. That's how we can do the problem. It's very simple way. And the next one is del and delta be the minimum and the maximum degree of the vertices of an undirected graph G. We show that del is less than equal to 2e by G, 2 of G by V of G. See, this one is E of G by V of G less than equal to delta. This is less than equal to 2 into E of G divided by V of G less than equal to delta. This is what we are going to prove, that we take E be the number of edges and V be the number of vertices, and let E minimum be, we represent the min as minimum degree of a vertex in graph, and max we represent as maximum degree of vertex in a graph, and every vertex's graph must lie between this minimum and maximum limit. So I write this as minimum less than equal to degree of V less than equal to max, and this one is separated. Then minimum less than equal to, I write the degree of V. What is the degree of V? It is also represented by Handshaking Theorem as 2e. So I write it as minimum less than equal to 2e less than equal to maximum. So using this n, that's for n vertices in a graph, I write it is for all the n vertices, n into minimum less than equal to 2e less than equal to n max. So I am dividing by n throughout. Then we write it as minimum less than equal to 2e by n less than equal to max. So m by n we can represent, that is 2, minimum is del less than equal to twice of E of G divided by V of G. What is n we took? What is here n? N is the number of vertices. N is the number of vertices here. Remember that. So I am dividing by this. Actually this one is E. 2 twice of E by n less than equal to max less than equal to your delta. That's how we got this theorem. This is a small, it's not a theorem, it's just a proof. We are proving that the minimum is all minimum, between the minimum and the maximum is 2 times of edges divided by the vertices. Twice of edges and divided by the vertices. And how many edges are there in a graph with 10 vertices, each having degree 6? So all the vertices are having degree of 6. So how many totally it is having? The sum of all the degrees of the vertices is 6 into 10. So it is 60. By the Handshaking Theorem, we say that this degree of sum of all the degrees of the vertices is 60 is equal to 2 times of E. And E represent the edges. Now I am representing here as a 2. So the number of edges, how we have to get? 60 divided by 2. This implies that E is equal to 60 by 2, which is equal to 30. It's a very simple problem. These are all very, very simple problems. Prove that a complete graph with n vertices contains n into n minus 1 of by 2 edges. So I am going to prove this by mathematical induction. By mathematical induction, we already done so many problems in mathematical induction. So we take first n is equal to 1 and 0 edges are required here. So n equal to 1 means it is vertices. The number of vertices is 1. This is a vertex and this is type of n when we have, it's a 1 vertex only. There is no edges for this, so we represent n equal to n minus 1. So here it is n minus 1. 1 into 1 minus 1 by 2, which is equal to 0 only. 1 minus 1 is 0. So 0 edges here we got it. So n into n minus 1 by 2 edges. How many edges are there for 1? n is equal to 1. n equal to 1. It's a single point. For single point, the edge is 0 only. The edge is 0. Assume that a complete path k vertices are there. Then we say that k into k minus 1 by 2. When we add the k plus first vertex, for k vertices it is k into k minus 1 by 2. But when I take it as k plus first 1, then we denote it as k into k minus 1 by 2 plus k is equal to k plus 1 into k plus 1 minus 1 by 2. See, instead of a k, I write it as, instead of n, I'm going to write it as k plus 1 here, and again k plus 1 minus 1 by 2. So that's what I written as a k plus 1 into k plus 1 minus 1 by 2, which is equal to k plus 1 into k by 2. So we got it as k into k plus 1 by 2. So here we are representing as k minus k into k minus 1 by 2 plus k. How many vertices will be having? We are having one more k only. We are adding k original vertices with requiring k additional edges. So I write it as k into k minus 1 by 2 plus k in your left hand side. So how many? First n is equal to, here what is your n? N is equal to k plus 1. So I write it as here as k into k minus 1 by 2 plus k, which is also equal to, here I am replacing this n into n minus 1 by 2 as k plus 1 into k plus 1 minus 1 by 2. So that's, we are done with this mathematical induction. We proved that the complete graph with n vertices contains only n into n minus 1 by 2 edges. And now I'm going to talk about graphs. In types of graphs, some more graphs which are the subgraph. What is a subgraph? It's also a simple graph, which is, no, it's not a simple graph, but it's a graph which is from the graph G. Some only few are being taken from the original graph. Then we say it is a subgraph, whose sets of vertices and sets of edges are all subsets of G. Since every subset is a subset of itself, every graph is a subgraph of itself. See, just like removing is, no? If I say 1, 2, 3, 4, and this is a set A, if I say that B is equal to 1, 3, 4, or C is equal to 1, 2, 3, and we say that B is a subset of A, similarly C is a subset of A. This is what it is, subsets. Subset means you are having some points we will be eliminating and will be, but even then it is a graph of the original graph. From the original graph, only a few sets we are taking and writing. So this is called a subgraph of the set. I am relating now with this here with your algebra. A graph, subgraph, S of a subgraph G is a graph whose sets of vertices and sets of edges are all subsets of G. Since every set is a subset of itself, every graph is a subgraph of itself. See the example here. In this example, the two lines are being removed, but originally this is the first graph. These two lines have been removed here. And this is a subgraph of this. Again, when I remove one more line, this line is removed here. So this is a subgraph of this. Again, few more lines have been removed. I just draw only an L shape, an inverted L shape. So you'll get it. And this is also a subgraph of the original graph. And even the only one single line which I draw, this is a subgraph of the initial graph. A vertex-induced subgraph is one that consists of some of the vertices of the original graphs and all the edges that connect them into the original. An edge-induced subgraph consists of some of the edges of the original graph and the vertices that are at their endpoints. See, this first example is a vertex-induced graph. It consists of some of the vertices of the original graph. What is a vertex? Vertex means only some few vertices. From few vertices, see here 1, 2, 3, 4, 5, 6 vertices are there. 6 vertices, 1, 2, 3, 4, 5, 6 vertices. I remove some of the vertices. I am not taking all the vertices, only 4 vertices I am writing. And here also 4 vertices I am taking it. The edges that connect to the original. Original, it is how it is connected. It's the same thing here I am connecting here also. So this is also a vertex-induced subgraph. This is a subgraph of this, and this is also a subgraph of this. This is a subgraph of this, and this is also a subgraph of this. And edge-induced subgraph consists of, now I am going for the edge-induced subgraph. It consists of some of the edges of the original graph and the vertices that are at their endpoint. See, in this edge-induced graph, I am taking only 4 edges. 1, 2, 3, 4. This 4 vertices I take it and just draw the 4 lines. And this is an edge-induced graph. And also this one, I am not drawing this one, and this line I am not drawing here, but even then it's an edge induced, it is a subgraph of that. So this is an edge induced subgraph. And now, what is a spanning graph? A spanning subgraph is a subgraph that contains all the vertices of the original graph. Original graph, how it will be, same thing it will be having also the subgraph. That is called as a spanning graph. A spanning tree is a spanning subgraph that is often of induced interest. In a graph theory, the complement, now I am going to go over the complement. What is complement? We have learned about in the set theory that complement means the set which is not including that. But here the diagram will be, then it will be having a different one. If I say that A is equal to 1, 2, 3, 4 and E is this element which is having 1 to 10. And what is A dash? We say that A dash is the complement. In that case, the 1, 2, 3, 4 we won't write. Only the 5, 6, etc. up to 10 I am going to write it and say that is the A dash is the complement of this. Complement or inverse of a graph G is a graph H on the same vertices. Now see this diagram, graph G. It is a graph H on the same vertices such that two distinct vertices of H are adjacent if and only if they are not adjacent in G. It is not, however, the set complement where only the edges are complemented. Edges alone will be complemented, but all the vertices will be same. See 1, 2, 3, 4, 5. 5 vertices are there in this. Even here the 5 vertices are there, but the connection between the 5 vertices have been completely changed here. This complement, this is joined like this, but these two are not joined, and instead of that I am joining this one. See here it is joined like this, and these two are made. The square shape joining is not that, only the cross shape joining are there, and this point is joined to this or not, it is, but here it is joined in a different way. This is the complement of a graph. It is something which is all the edges connecting will be different. That is called as complement of a graph. The rest topics of this unit are isomorphism, independent sets and coverings, operation of graphs will be covered in the next PPT. And then thank you for watching this. And one more thing, please try the problem of Königsberg bridge. Whether it's possible to cover the distance, maybe cover all the 7 bridges without walking on it twice from one part of an island to another part of an island. Try this alone. Thank you, students.